Well, as I showed you last time, and you really ought to kind of, if you got any kind of a visual memory, these two triangles are going to be similar. So assuming, of course, this is a right angle and this is a right angle. So I can chop off this triangle, and I can bring it over here and just flip it. Actually, I don't even have to flip it, I can just take it right over there. Okay? And I can put it on here, and now what we've got is we've got a rectangle here. What's the length? Well, what's the length of this rectangle?
A.
It's A, right? Because this side is A, this side is A, if it's a parallelogram. So this is A. Okay, what's this side?
B.
It's B because that was here. And that's B because it's between two perpendiculars, okay? Or it's perpendicular to the two sides that we'll call bases, okay? So it doesn't matter where we move this, as long as it stays perpendicular. These sides are parallel. Its length is not going to change. So we got A times NB. So the area a little cramped there, but I just wrote areas, length times width, as you almost certainly know. That's A times B. In terms of the parallelogram, we call this thing, wherever it is, an altitude. And this side or this side can be regarded as the base, and it's base times altitude. Okay? Now, I saw a couple of answers, I think, that did half the base times the altitude. Why would somebody do that? Well, there's a pretty good reason. Just a little confusion between formulas. If you do half the base times the altitude, what's that give you the area of? Well, anybody gesture with their fingers? It's one of these things. What's that? Triangle, right? I mean, not a very good triangle. My fingers aren't all that straight. Okay? So if you take half of this, you get the area of a triangle. Since I saw half of this on at least one paper, I think a couple, that's worth storing away. Because, of course, if I cut this thing in half from this point to this point, I've got a triangle. It has half of the area of the parallelogram, and that's where the 1/2 base times height comes from. Okay? It's not some mystery that was handed down on a stone tablet. There's a good reason for it, and a pretty straightforward reason. If you understand how to reconstruct a parallelogram into a rectangle, then you get the formula for both the area of the parallelogram and the area of this triangle. Okay? That might be a little hard to think that way because you've been taught to just memorize stuff. But push yourself a little bit because it'll benefit you. Okay. Now if you just remember the formulas, know how to use them, okay. But better if you understand where they come from. Okay. I screwed up this problem. I didn't tell you what to do. I just wrote it down. Okay? The problem here is to find I didn't even give you enough information. Okay, I wasn't being real smart there. We'll come back to this. You have problems of this nature, in the homework, and it was glaring that almost nobody got them. Okay? Similar, problems with similar triangles. So I need more board space to state this problem. So I'll do one with numbers. Matter of fact, I'll go ahead and do one with numbers right now. Okay, so let's say this is 4 here. And changing it a little bit, let's say this is 5. And let's say this is 12. And this is X. How would you be able to tell me what X is? Since people had trouble with this, I'm going to go ahead and tell you. I'm not going to drag it out of you. Okay? I'll drag it out of you maybe next time. Okay, well, here we have it. What we can say is this little triangle here is similar to this big triangle. So let's just make this little triangle blue. And the big triangle is going to be orange. Okay? Okay, so the big triangle is similar to the little triangle, meaning the ratios of the sides are the same. Okay? So what we're saying is, if this side is twice as big as this side, it isn't, but if it was, if this side is twice as big as this side, then this side is twice as big as this one, and this one is twice as big as this one. Okay? Everything is twice as big. Which means that the ratio of this side to this side is the same as the ratio of this side to this side, which is the same as the ratio of this side to this side. Okay? So I can redraw these triangles, and they're similar because they've got identical angles. Okay. This angle is implicitly 90 degrees. I didn't draw it that way. Let's just say, okay. I mean, I didn't include the symbol in it, so it looked the same. Okay, this angle is the same as this angle. This angle is the same in both, right? Okay? And that means this third angle is the same in both, which it obviously is anyway. Okay? So this third angle is the same in both. So they have all the same angles, so all the sides are in proportion. Now this is something I would assume that everybody had learned in geometry, similar triangles. That was back in 8th grade, and you probably never used them again. Or if you did, it was in the algebra class and you're struggling with everything else, and you kind of overlooked that, okay? Or you just plain old forgot it, which means nobody asked you to do enough of it. But okay, here. And if they did, again, I'm not blaming your teachers, and you shouldn't either. They're struggling with this silly curriculum. Okay, trying to do the impossible, which is teach geometry and algebra to people who don't want to learn it. Okay, anyhow. So if this side is, let's say, using letters, I'm going to say P, Q, and R. Okay? And down here, I'm going to say P hat, a little hat on top of the P. I should have drawn that in blue. Sort of. Q hat and R hat. Then the fact that these sides are in proportion is I'm gonna write it all out. Angles. Are the same, implies, it's not an equal sign, that's a arrow with a little bit of attitude. Angles of the two triangles the same implies similar. And I'm going to say corresponding sides are in the same proportion. Yeah, I'm going to say i.e. that is, they have the same ratio. So, Q over Q hat has to equal P over P hat has to equal R over R hat, because these are the corresponding sides. Okay. R is opposite the right angle. R's hat is opposite the right angle. That's how you tell they're corresponding. Okay. And then the lesser angle tells you where P is, the greater angle tells you where Q and Q hat are. Okay. So what do we want? We could say that 12 over x has to equal P over P hat. Because, of course, your Q and your Q hat are 12 and x, right? Okay, so Q over Q hat is your 12 over x. Well, what's P? Anybody show me with their fingers? How many fingers you need to do P? P is this side. Yeah. Got more? Okay. So at least one person has enough fingers. I think most of you have enough fingers. Hadn't checked. Okay, well, this is 4 and this is 5. That adds up to 9. P is 9, right? So 12 over x equals 9 over what's P hat? Fingers. Show me P hat. Well, I mean, here's your blue triangle, right? P hat is 4, right? Then how do we solve this? Now, people will cross multiply. Okay? I really don't particularly like cross multiplication. It's just like cancellation. People often do it wrong because they don't really understand the rule. I would say your common denominator is 4x, multiply both sides by 4x. Comes out the same as cross multiplication. But in any case, what you end up with is some dots. Nine x is 48. So x is 48 over 9. Now, you're all good at this stage, so you know what to do. And of course, you can divide both by 3. 16 over 3, 16 over 3, 5 and a third. Okay? They really ought to be able to do this. You're going to need to be able to do similar triangles many times. If you're going to be in pre-calculus, your second semester is all about triangles. If you don't understand similar triangles to start with, you're going to be hurting it immediately, okay? So make yourself a note. Review similar triangles. If you want me to, email me, and I will set up a little optional exercise in my open math for similar triangles. Okay? It would benefit you, not for pre-calculus 1, and this is preparation for pre-calculus 1, but we don't have a preparation course for pre-calculus 2. But you figure if you get through pre-calculus 1, then you'll have what you need to succeed in pre-calculus 2. And I'll warn you, pre-calculus 2 is tougher than pre-calculus 1, okay? Gets into all the trigonometry, it's much more difficult course. If you need pre-calculus 2, which you probably don't for the field you're likely to go into, unless you're going into engineering or some of the hard sciences like chemistry, physics, and stuff, and mathematics. Okay, and hard doesn't mean difficult. Hard means you can get your hands on physical things and chemical things. Now, a lot of chemicals you don't put your hand in, but that's a different story. Okay? And some of the schools you might want to transfer to are going to require 2 semesters of pre-calculus. Going into business, there's no good reason for that I can fathom, and nobody's ever been able to tell me one, but they want it, okay? Mainly because they want people who are disciplined enough and mathematical enough, because there is a mathematical aspect to business. Just picking a business, many of them, business because a lot of people want to go into business. Because it's more relevant to more people. But talk about the soft sciences, psychology, social science, and so forth. Even biology. Most biology, you don't need trigonometry. Some schools require it, so you're kind of stuck to it. If you're going into those fields, you want to transfer to those schools. Okay? Otherwise, you're probably better off just taking a pre-calculus 1, statistics, and applied calculus, which is, in fact, no harder than pre-calculus 2, and I think a little easier. First semester applied calculus. Okay, well, anyhow, enough about that. If you ever want to talk to me about that, whether you're my advisee or not, I'm glad to talk to you. Okay?